So an x-intercept is when your y is equal to 0. So in the graph, your x-intercept would be right there where your y value is 0. So to find that location, I'm going to take the equation, substitute 0 in for y. So we have 3x equals 15, divide by 3. And I know that my x-intercept is now at 5. Next, for your y-intercept, to find a y-intercept, which is there, you make x equal to 0. Because any value on the y-axis has an x value of 0. So again, we're going to substitute 0, but this time in for the x. So 5y equals 15. If I divide over the divide by the 5, I get a y value of 3. So my x-intercept is at the ordered pair 5, 0, and my y-intercept is at the ordered pair 0, 3. This next slide, I'm asking you to find approximate and exact values for x-intercepts. So again, we have this cubic is graphed here in a nice little graphing window. And the cubic graph appears to have, or does have, 3 different locations where it's crossing the x-axis. So by zooming in, you can look at the x values here for the original window. Here I zoomed in on that window so that we could get a better look at that area right there. And it looks like one of the x-intercepts is at 0, and the other x-intercept is somewhere between -8/10 and -6/10, close to probably -7/10. So I blew up that section over here by changing the window, and this time this is -7/10. So it appears, if I were to approximate that x value is at approximately somewhere around 73/100, -73/100. And then this y-intercept, if I were to approximate it, I blew up the window because it looked like it was between 2 and 3, and actually more between 2.5 and 3. So I blew up that section. There's that one, and that x looks like it's somewhere maybe about 2.73. Okay. So that's how you can approximate. You can zoom in on the graph. But now we're going to find the exact intercepts by hand. So to find the x-intercepts, again, that's when y is equal to 0. So 0 equals x cubed minus 2x squared minus 2x. I can see that I have an x in every term, so I'm going to factor it out. And if I were to try to factor that, it would not factor into nice integer values. So I'm going to try the quadratic formula. So here, I know one of my x-intercepts is at 0, as we saw on the graph, but to find the other 2 x-intercepts, we're going to make that equal to 0, and again use the quadratic formula. So a is 1, b is -2, c is -2. So x equals the opposite of the b value, plus or minus the square root of b squared, which would be 4, minus, and I'm going to take the 4 times the a times the c, that gives me -8. So that's going to actually become a positive value in there. Divided by 2 times a, 2 times 1 is 2. So x is equal to 2 plus or minus the square root of 12 over 2. Again, square root of 12 has a perfect square value that divides into it. So if I take, I'm going to write it up here, square root of 12, the perfect square value that goes into 12 is 4, goes in there 3 times, and I can reduce the square root of 4 to 2. So my x value is 2 plus or minus 2 root 3 over 2, which simplifies. I can divide the 2 into both of those into 1 plus or minus root 3. So there are my other two values for my x-intercepts. For my y-intercept, that's my x is 0, so y is equal to 0 cubed minus 2 times 0 squared minus 2 times 0, which is 0. And if you remember the graph, it did cross at the origin, which was 0, 0. So we have 3 x-intercepts, 1 y-intercept. So I would like you to try to find the x and the y-intercepts of this equation. X squared y minus x cubed plus 3 equals to 0. Okay. So for this first one, y is 0, so x squared, 0 for the y value. Basically just cancels that out. That would be 0. So I have negative x cubed plus 3 is equal to 0. I'm going to add over the x cubed. So 3 is equal to x cubed. And then x is going to equal, to get rid of the cubed, I'm going to take the cubed root of 3. So this graph only has one x-intercept, and it's at the cubed root of 3. And the y-intercept, I'm going to put x 0 in for x. So 0 squared times y minus 0 cubed plus 3 equals 0, which that's 0, and 3 does not equal 0, so there is no y-intercept at all. So this graph does not cross the y-axis. So what I have here, same equation that we just talked about, but we're going to look at it on a graphing calculator or graphing utility. So first thing we need to do is solve that equation for y. So to solve that for y, I have x squared y. I'm going to add over the x cubed and subtract the 3, and then divide by the x squared. So I have x cubed minus 3 divided by x squared. So I solved it for y. I typed it in my calculator, and this is the graph that showed up in a standard viewing window. So what I'm going to try to walk you through here is a way that you can, without approximating, a way to find that x-intercept, which we already found by hand, but we want to see if there's a way to do it on our calculator also. Note, there is no place where the graph is crossing the y-axis because we already found out there was no y-intercept. So, up here I tried to write out the ways to do this. So if you go to second and the trace key, above the trace key it actually says calc. And if you go to second trace or the calc key, you want to go down to 2, the second one, which is 0. So this is the menu you would see. And we want to go down to calculate the 0. Meaning where the x, what value for x will make the equation equal to 0. So when it does that, you get this type of a graph over here. And it asks you, where is the left bound? So I can see that it's crossing my x-axis in that location. So I arrowed over to the left of the x-intercept. And that's going to be my left bound. And once you do that, you hit enter. Then the calculator is going to ask you, where's the right bound? Can you go to the right of where the x-intercept is? So I arrowed over, using my arrow keys, over to this location. And when you get there, you press enter. Then it's asking you, can you guess approximately where that x-intercept is? So again, I arrowed over to about where it looked like it crossed at and hit enter, and it gave me the value of where it was equal to 0. is your lesson on graphing calculators.